So the first question we're going to look at today is example 34. Now, example 34 says that if sine A is equal to 5 over 13 and cosine B is equal to 3 over 5, and that A is obtuse. So, very important, A is obtuse. Now, an obtuse angle is between 90 and 180 degrees. And if A is obtuse, it means that A lies in the second quadrant. B, we're told, is acute. Now, if B is acute, it means that B is less than 90 degrees, and B is in the first quadrant. We're to find the value of these. So A, we need to find what is sine A plus B. Now, using the compound angle formula, sine A plus B is sine A cos B plus cos A sine B. So, so far I already have what is the sine of A, which is 5 over 13. Notice, if I want to find out what is sine A plus B, I need to also know what is the cosine of A. We also know that the cosine of B, which is acute, is 3 over 5. But the formula for sine A plus B also require that we know what is the sine of B. Now, to find this out, what I'm going to do is I'm going to draw a triangle that includes A, this triangle, it's a right angle triangle, and I'm going to call one of the angles in the right angle triangle A. So this is my right angle triangle. And this angle here, I'm going to call A. And I'm doing this so that I can determine what is the cosine of A, because it is important for me to know, or in order for me to find out what is sine A plus B, I need to know what is the cosine of A. Now, the sine of A is opposite 5 over hypotenuse 13. So this side is opposite to A. This side is the hypotenuse. So what I need to find is this side, which is adjacent to A. Now, I think if you are aware of your right angle triangles, you will know that if you have a right angle triangle where the hypotenuse is 13 and one side is 5, that the next side must be 12. Now, if you know this, you do not need to apply Pythagoras theorem. You could just write that that third side is 12. However, if you don't know it, and since you know two sides, you could use Pythagoras theorem to determine the third side. So from this, I can see that the cosine of A is adjacent 12 over hypotenuse, which is 13. But since A is obtuse, meaning that A is in the second quadrant where cosine is negative, the cosine of A would be minus 12 over 13. All right, I also need for my formula the sine of B. So I'm going to do a similar thing. I'm going to draw a right angle triangle. This one not working out for me at all. So I'm going to draw a right angle triangle. I'm told that the cosine of B is 3/5. So if this angle is B, this is the angle B, cosine is adjacent. So the adjacent is 3 over hypotenuse. So the hypotenuse is 5. And from my knowledge of my right angle triangle, the opposite side, the side opposite to B, must be 4. Again, if you do not know this, you could use Pythagoras theorem to determine the length of the unknown side. So from this now, I can say that the sine of B, which is equal to opposite, which is 4 over the hypotenuse, which is 5. Now, since B is acute, the sine, cosine, and tangent of every acute angle is positive, so the sine of B must also be positive. Now, once I know this, I can now say that sine A plus B would be equal to sine A given 5 over 13 times the cosine of B, which is given 3 over 5, plus the cosine of A, which is minus 12 over 13, times the sine of B, which is 4 over 5. All right, so this would work out to be, let's say 15 over 65 plus, sorry, not plus, this is minus because a positive times a negative is a negative. And we have 12 times 4 is 48 over 65. And so my answer would be minus, and this looks like 33 over 60 over 65. So the sine of A plus B would be minus 33 over 65. All right, so let's do the B part of the question. In the B part of the question, we're asked to find the, so I don't have any space for it. We're asked to find in the B part of the question the cosine of A minus B. So this would be equal to the cosine of A, the cosine of B, plus the sine of A, the sine of B. All right, let's take this up here. So this would be equal to the cosine of A, which is minus 12 over 13, times the cosine of B, I think this was given, which is 3 over 5, plus the sine of A, which is 5 over 13, times the sine of b, which is 4/5. So this would be equal to minus 36/65 plus 20/65. The answer here looks like it's minus 16/65. So the value of cosine A minus B would be minus 16/65. All right, so next we're going to look at example 35. So here's example 35. Example 35 says, given that the sine of A is minus 2/5, and that is already telling me something about A. A is either in the third quadrant or in the fourth quadrant, because it is in the third quadrant and the fourth quadrant where the sine of an angle is negative. The cosine of B is positive 1/4, and it says A and B are in the same quadrant. So this is a quadrant in which sine is negative and cosine is positive. That is clear. It means that A and B is in the fourth quadrant. In the fourth quadrant, sine is negative and cosine is positive. So both A and B are in the fourth quadrant. Now, we're told that the sine of A, so sine is opposite over hypotenuse. So the sine of A is minus 2/5. If we use Pythagoras' theorem, the side that is adjacent to A is going to be the square root of 25 minus 4. That would be the square root of 21. Because 5 square is 25. If we want to, we could say that 5 square is equal to 2 square plus x square, x being the side of unknown length. So this is 25 is equal to 4 plus x square. X square is equal to 25 minus 4, which is 21. X, the opposite of square is square root, is the square root of 21. So the side adjacent to A, the length of that side is the root of 21. So with that knowledge, I can now say, well, this was given that the sine of A is minus 2/5. And now I can say that the cosine of A is adjacent root 21 over the hypotenuse, which is 5. We're also told that the cosine of B is 1/4. This is the side adjacent to B. 4 is the hypotenuse. So now the side that is opposite to B, using Pythagoras' theorem, it will be the square root of 16 minus 1, which would be the square root of 15. So now I can say that the cosine of B is 1/4, and this is given, and that the sine of B, now since A and B are both in the fourth quadrant, sine is negative, so the sine is going to be minus root 15 over the hypotenuse, which is 4. Next, we're asked to find the value of the sine of A plus B using the compound angle formula. The sine of A plus B is the sine of A, the cosine of B, plus the cosine of A, the sine of B. Substituting in our values, we have the sine of A is minus 2 over 5. The cosine of B is a quarter, plus the cosine of A is root 21 over 5 times the sine of B, which is minus root 15 over 4. So far what this looks like, it's minus 2 over 20. And here we're going to also have a minus. This is minus root 21, root 15. So we have the root of 21 times the root of 15. And that is actually equal to 3 root 35. So this is minus 3 root 35. And this is all over 20. Let's make this into one fraction. This is minus 2 minus 3 root 35 all over 20. We can factor out the negative and say it is minus 2 plus 3 root 35 over 20. All right, next we're asked to determine the value of cosine A plus cosine B. So cos A plus B, cos A plus B is cos A cos B minus sine A sine B. All right, so now we have the cosine of A, which is root 21 over 5, times the cosine of B, which is a quarter, minus the sine of A, minus 2 over 5, times the sine of B, which is minus the root of 15 over 4. So here we have root 21 over 20 minus, if you multiply 3 negatives, it must come out negative, 2 root 15 over 20. As one fraction, this is the root of 21 minus 2 root 15, and this is all over 20. All right, let's view the entire question.